This is section 12, function analysis, example 11. So now that you've learned about the first derivative test and finding where it's increasing and decreasing and local max and local minimum, we're going to apply the same ideas to linear motion. So imagine that you have this object and it's either going up and down or left and right, not both. Okay, it only has one direction, or it's only moving in two directions, either left, right, or up, down. You don't have to worry about it moving up and to the right at the same time yet. Okay, so we know how to find the velocity of a function. You take the derivative of the position, right? We've done that. And we know that when the velocity is 0, the ball has stopped and it's moving in the other direction. Okay, we know that too because we've done that before. When we're talking about the movement, though, if we want to know which direction it's moving, then we look at the sign of the velocity at a particular point in time. So if it's positive, let's say it's just moving left and right, right? If it's positive, it's moving to the right. If it's negative, it's moving to the left, right? Because when you think right, you think positive values. When you think left, you think negative values, okay? If it's 0, then it's stopped moving in a particular direction and is about to move the other direction, okay? And the same thing happens when you're moving up and down, right? Positive is up, negative is down. We also need to know that the speed is the absolute value of velocity. So that's important. If it ever asks you about speed, you take the absolute value. Then we have acceleration. Now the derivative of velocity is acceleration. So acceleration tells you which direction it's accelerating in. It also tells you the rate of change of the velocity because it's the derivative, and so it's the slope of the secant line of velocity, of the tangent line. And when we put those two things together, we find the speed, whether it's speeding up, slowing down, or just stopped. Okay, so you imagine you're riding a bike. Okay, you're riding a bike to the left, and then a sudden gust of wind pushes you, right? Or a gust of wind approaches you. Now, if that wind is strong enough, it's going to stop you and push you backwards, okay? So if you have an opposing force on you as you're moving to the left and that wind is moving to the right, it's going to slow you down because that opposition is there. Eventually, if the wind gets strong enough, so if the acceleration is strong enough, it's not only going to stop you, it's going to push you in the wrong direction, right? It's going to push you back to the right, and that's what's going to cause that. Now, once you're moving to the right, if you're moving to the right and acceleration is moving to the right, it's just going to push you that way even faster, right? Because there's no resistance against you. It's just everything agreeing with each other. So that's what's happening here. Now, let's go ahead and do example 11. An object moves along a horizontal line so that its distance s, it's supposed to be s, from the origin at time t is greater than or equal to 0 in seconds is given by this equation. Okay, before I do anything, I'm going to go ahead and find my critical points. I'm going to graph all the sign graphs so that I have it. I'm going to find a velocity graph, sign chart, and an acceleration sign chart. So first, we know that s of t is t cubed minus 9t squared plus 15t plus 3. All right, so velocity is the derivative of that, which is 3t squared minus 18t plus 15. So I'm going to go ahead and solve that for the zeros. So I get t squared minus 6t plus 5. So that becomes t minus 2, t minus 3. Nope. That's wrong. It's t minus 5, t minus 1. So t equals 5 and 1. Okay, so those are my critical values for my velocity sign chart. I'm not going to graph it just yet. First, I'm going to find acceleration. Okay, so I take the derivative of that to get acceleration. And so I get 6t minus 18. When if I take out 6, we get t minus 3. So t equals 3 is that critical value. Now I'm going to make my sign charts. So I'm going to have one for velocity. Okay, I'm starting at 0. I'm going to have one for acceleration. That starts at 0, 2. I'm going to have one for motion. And that tells me that's going to determine whether I'm speeding up or slowing down. Okay, and I kind of want them to all overlap. So I've got 0, 1, and 5 for velocity. I've got 0 and 3 for acceleration. And then for motion, it's going to be all of them. So it's going to be 1, 3, and 5. Okay, so the sign for velocity is based on plugging in numbers again. So between 0 and 1, we've got, what, 1/2? That would make both of them negative, so that's positive. From 1 to 5, let's plug in 2, okay, which makes one of them negative and one of them positive, so that's negative. And if I plug in 500, I get positive numbers. For acceleration, we're now plugging into the acceleration equation. So t minus 3 times 6. If I plug in 1, 1 minus 3 would be a negative number, so that's negative. And then for 3 on, so 500 minus 3 is still positive. Okay, now the sign of motion is depending on whether velocity and acceleration agree with each other or not. Remember, if the wind is pushing you in the same direction that you're moving, that means the signs agree, and that's going to speed you up. But if they're opposing, if our wind is pushing against our velocity because they're going in the opposite direction, then it's slowing down. So we look at the signs. So a positive and a negative between 0 and 1 make it negative, so it's slowing down. And then the negative make it speed up because it's in the same direction. Negative positive means it's slowing down. And positive means it's speeding up again. All right, so now that we know all of this information, let's answer the questions. First, we need to figure out where it's moving to the right. That's based on velocity. Velocity is the direction it's moving, and that means it's positive. So positive velocity occurs between 0 and 1 and 5 and infinity. For the left, it's still velocity, but it's the negative, so it's between 1 and 5. When does the object reverse direction? Well, according to our sign chart, it's going to move right, then left, then right. And it reverses direction at our critical values. So that would be t equals 1 and 5. When is the velocity increasing and decreasing? Well, velocity is increasing when acceleration is positive. And velocity is decreasing when acceleration is negative. So it would be increasing based on the acceleration time sign graph. So it would be from 3 to infinity, and decreasing from not negative infinity. Time doesn't have negative infinity. That doesn't make any sense. From 0 to 3. When is it speeding up and slowing down? That's the motion part. Okay, so speeding up when our motion is positive, so 1 to 3 and 5 to infinity. Slowing down that's the negative, so 0 to 1 and 3 to 5.